Okay, so question number one says that the fraction 578 over 999 is a repeating decimal. So if you enter that on your calculator, you will see that it gives you 578578 repeating. So it wants to know what the 85th digit is. So you'll notice the pattern is we've got 1, 2, 3 in a row, and then 1, 2, 3 in a row again. What that means is that if you notice 8 is the third digit, then the sixth, it would be the ninth, and so on. So any multiple of 3 would be an 8. So what we're going to be able to do is take 85, which is not a multiple of 3. The way to tell if something is a multiple of 3 is add whatever digits together, in this case a 2-digit number, and see if that number is divisible by 3, which in this case it is not. So 85 is not a multiple of 3. But 8 plus 4 is 12, which is divisible by 3. So awesomely, 84 is a multiple of 3. Any multiple of 3 is an 8. And since it is one more than that, it is 85, not 84. Since it is one more than that, my answer is 5. Question number 2, make sure you follow your order properly. I need to follow PEMDAS, and absolute value falls under PEMDAS. So that is actually a 2 up front, minus absolute value of negative 2 is 2 again, plus 3 would be the 2's canceling out, leaving me with a 3. So just be very careful with absolute values. Don't turn everything positive inside until you have reduced what is inside the absolute value. Number 3, pretty much trial and error. However, it does say a is an odd integer. Integer means nice rounded numbers. They can be positive or negative, but nice and rounded. So for a, it says it's an odd, so let's pretend that a is 3, just because we're plugging in and doing a little trial and error. B, it says is even, so let's just start going through and plugging in. You'll notice for A, I would get 6. For B, I would get 6. For C, I would get 10. For D, I would get 3 plus 2 times 2, which is 7. That is the only odd. If I plug in to E with my choice of 3 and 2, I would also get 8. So I can see that the only one that gives me an odd is D. So kind of a trial and error. I do need to go to the answers like we discussed before. What is a remainder? Do you remember how to do a remainder? So 45 divided by 6 longwise. 6 goes into 45. You need to stop and think for a second. That would give me 7. 7 times 6 is 42. 3 left over. That is a remainder of 3. I know that's a little childish. However, they do make an appearance occasionally, particularly on the SAT. Difference between largest and smallest factor of 20. Factors of numbers are numbers that multiply to give you that number, and they have to be whole numbers. So they can't be decimals or fractions. So 1, 2, 4, 5, 10, and 20 are all factors of 20. So kind of interestingly, I'm only dealing with 1 and 20, since I'm taking the largest, which would be 20, and the smallest, which would be 1, and they want the difference. Difference means to subtract. So the difference between the two would be 19E. All right, so smallest multiple of 15 that is not 15. Here's the trap on this one. It says small, and as soon as they say small, you're thinking something smaller than 15. It's the smallest multiple is really the word we should be focusing on. So we're looking for something that multiplies 15 and another number, but it wants the smallest one that is not 15. Technically 15 and 1 is a multiple of 15, so 30, 15 times 2, would be the answer we're looking for. Which of the following is not a rational number? That would imply irrational. So irrational numbers are numbers that have a decimal that doesn't repeat. Usually you're looking for roots or pi. However, you do want to simplify any roots that are present. So square root of 4 is 2. So negative 4 is nice and rounded. 2 is nice and rounded. 0 is nice and rounded. 4 over 3 is tempting. However, that is 1.3 repeating. So repeating is actually rational. Rational means you can write as a fraction. If something is repeating, it can be written as a fraction. So that leaves my answer of E. Square root of 3 is a never-ending decimal that does not repeat. All right, matrices. A lot of you have not seen these before. Usually on the ACT, they don't ask anything any more difficult than adding, subtracting, or multiplying scalar-wise, which is what we're going to see here. So all you do is add by position. 3 plus a negative 2 is 1, so automatically G is tossed. Let's add another. Looks like 6 and 2 added together, so that's 8, 8. I is gone now. And finally, looking at the two answers left, bottom left is the same. They're both 7, so I'd rather not do that one. How about the 0 and the 10? 5 plus a negative 5 is 0, so F is my correct answer. How about subtract? So subtract, I'm going to take 3 minus a negative 2. 5. There is only one answer with 5. Now, I do want to be careful. It does have a none of these answers, so going through the rest, I get 6 minus 2 is 4. 4 minus 3 is 1, and 5 minus a negative 5 is 10, so G is the correct answer. And last one, this is what they call a scalar multiply, so I'm not actually multiplying matrices. I'm taking everything inside the matrix times 3. So notice it says 3A. It's almost like distributing a 3 to every piece. So that would give me a 9 in the upper left. So H and I are tossed. So that's that 9 I was looking for. Upper right would be 6 times 3, 18. So it looks like my answer is probably going to be G. I should finish that out. 3 times 4 is 12. And 3 times 5 is 15.